All right. So, what we're going to talk about today, or look at today, is using the sfml library. Last time we talked about libraries and this kind of idea of using someone else's code or code that was written by a person, an organization, a development team, whoever actually wrote it. But otherwise, the library itself exists as a way of helping you or some other programmer that wants to use it to do something that maybe they don't know how to do on their own, or they don't have the time to write that kind of stuff themselves. They don't have the interest in writing that sort of stuff themselves. Otherwise, it's a solution to some kind of problem that could potentially help you in solving some larger problem that you have. And a lot of times we'll talk about this sort of stuff as solving problems, right? Not in the traditional sense of like solving a math problem, solve for X or what is A plus B or whatever. But solving some sort of a problem is, well, we're in a scenario where we need to do a thing or produce some kind of result, and we can't quite do that just yet. Something is impeding our progress, or there's some amount of work to do that we either need to figure out how to do, or find the right combination of elements to stick together, or whatever else, right? So kind of broadly, we just call that solving problems, if you haven't already kind of picked up on that sort of terminology. So the library in question, this sfml library, the simple fast multimedia library, you will use this for your last project in the course, which is still a little ways off. But I wanted to take a look at it here and show you some examples of what you can do with it, at least on a basic level. Because if we encounter this kind of scenario, which we will constantly, we will very, very commonly be, maybe not constantly, maybe that's a slight exaggeration, but very frequently, we will encounter these kinds of scenarios where, okay, I need to use some external tool that someone else has written. I need to integrate this into my own code. How do I do that, right? And sometimes it takes a lot of learning. It takes a lot of research, a lot of experimentation, reading documentation to figure those kinds of things out. Okay, well, how do I use this? How do I take something that someone else has done and fit it into whatever I'm working on? And it's not always easy to do that. Sometimes things don't integrate very easily, right? It's kind of like metaphorically speaking, trying to fit a square peg into a round hole. Sometimes you have to do a lot of conversion and sort of reworking of one system or another to make the two pegs and holes kind of fit with one another. And so the sfml library, we'll talk about the exact installation of this later when you get to your actual project. I mean, you could certainly just go through some of their tutorials here. But once we have all of that set up, if we go to the Learn page, and then to tutorials, again, this assumes everything is already initialized. The very first link here, sfml and Visual Studio, they go through a bunch of stuff about how to set up a project for this and all that. Once we have all of that done, how do we know it works, right? How do I get something like this, which the developers say, hey, if you can do this, everything compiles and everything is going to work just fine. So we have this little bit of starter code here. And so I can come to my own project and, just overwrite all that with what we have here. And so we might look at this and say, all right, well, what are all of these things? I don't know what the heck a SF render window is or an SF circle shape. Like, what are all of these things? And then, we run this. We say, okay, well, let's just see what happens, and we get this tiny little circle here, right? And so it's a very small window. Let me make that a little bit bigger there. And, we can resize this, and we have, oops, there we go. We have, a circle that can move around and get kind of strangely distorted and whatnot. Like, all right, that's sort of cool. That's maybe more interesting than just a simple console window with some plain text. So that's a start, right? And so looking at what we've got here, just this little bit of code all by itself, there's a tremendous amount of stuff going on here. As I'm sure you've all, already started to pick up on this concept here. And I think somebody jokingly in the chat one day was like, I think this computer science stuff is maybe a little bit more difficult than it initially seems, which was a very humorous moment. So whoever that was, I'm sure you know who you are. Well done, once again. So we've got a lot of stuff to unpack even in 15, 20 lines of code here. So to start, we've got this object, this SF render window. Okay, so just looking at this right here, we've got a namespace, or even before all of this, we're including a header file. So the header file is sfml/graphics.hpp. So HPP is a C++ header file. Normally we've talked about them as just .h files. HPP is basically a way of saying this is a C++ only header file, because we might have a C file, the C language, which will use .h files. C++ will use .h or .hpp, but that's all that really means. So in this particular header file, which is located in this sfml folder, we have a file called graphics. And if we wanted to, we could right click on this and go to document and open this up, and here's the header file with a whole bunch of other includes. I mean, just looking at that list of include files, there's a lot of stuff within this library, right? So there's the circle shape that we had a little bit of code for that elsewhere, and render window, we had an object of type render window, and so on. But this one file is mostly just a whole bunch of includes. So if we wanted to go into the render window, we could do the same thing and kind of chase this rabbit hole, or go down this rabbit hole a little bit further and chase a rabbit down said rabbit hole. And looking in here, we've now got a class that looks to be deriving from other classes. So there we have multiple inheritance, and there's a constructor, there's another kind of constructor, and gigantic block comments for each one of these things to sort of describe what they do. And all kinds of various functions in here, right? And so there's a lot of stuff that's going on in this particular file. And this is just the one header file for this one class, one of many, right? So we don't need to understand every single line of code in libraries like this, but the code is there, at least the header files, if you want to go poke around a little bit and explore. So looking at this here, if we just run the program again, we'll see we have this console window in the background that we'll get back to that in just a minute. But then we have this window right here, which is fairly tiny. And if I scale this up just a little bit bigger here, so we have a title right here, sfml works, and that's the title of our window. So if we do something like COP3503 is the best, not to toot my own horn or nothing, but beep beep, then we could run this again, and now we'll have a window that says COP3503 is the best, as it rightly should. Or we'll get a compiler error because I clearly broke something. Oh, I forgot to close the program. If you ever get this error, if you have a program open and you try to build again, you may get this error here that basically just means, hey, I tried to overwrite this file, but I can't. So I'm not going to finish building the project. That's because the program is still open, and Windows is like, no, you can't delete this. Somebody's using it. So now we have a window that says that message there, right? And so if we wanted to change the size of this, I mean, just kind of looking at what we have right here. So we have a variable of type video mode being constructed. We don't necessarily need to know what video mode is, but this is going to be the width and the height of the window. So if I wanted to make this a little bit bigger, let's say we're doing, something like HD resolution, it's 1920 by 1080. And if we run this again, just close these windows down here. And then we get a much larger window, right? So we have a bigger window now, a tiny circle shape over here, and still this console window in the background, right? And so the console window can be very useful if we wanted to, print out some messages while our program is running. Just a regular cout print message will appear in that console window in the background. And so looking around at some of the other code that we have a circle shape right here. And if we look at the constructor of this circle shape, we've got, this is called a move constructor. We don't need to worry about that. This is a copy constructor. We don't need to worry about that. But then we have this one right here. So we have float radius with a default value of 0. Okay, so if I don't specify anything, the radius of my circle will be 0, right? So maybe I don't want that. So right now its radius is 100. Okay, well, if I just tried making that 200, then presumably I get a larger circle, right? And some of this stuff might seem kind of obvious, especially if you've ever done anything like this before. But whenever we're encountering some new kind of API or new library, it is extremely helpful that you just wait. Sorry, close the wrong window. Meant to just minimize that. It's extremely helpful that you just experiment, right? Look at the code that you have and basically push some buttons and see what happens, right? Change a little bit of code. What happens? Does this have any effect? If I change this string to something other than sfml works, does it do anything? If I change these numbers to something, does it do anything? What about all of these things right here? We're not dealing with a tremendous amount of code here. And even if we are, assuming you're not in some sort of environment where if this variable ever changes from 2 to 3, well, call the fire department because something's going to explode. You're probably not going to be in that sort of a situation. If you are, then don't change the variable from 2 to 3. Problem solved. But if you're not in that situation, play around, experiment, change some numbers, see what happens. Because when you first start out with this sort of stuff, we're in a state of knowing basically nothing about all of this, right? What does all this do? I have no idea. I cannot answer any questions about this. I don't know anything. Okay, what could you do to find out something? What could you do to learn about some of this stuff that you're working with? And then just go, and push some random buttons, right? So playing around with this will help us learn what various things do. So if I change this number from 100 to 200, oh, okay, I get a circle that's twice as big. Cool. Here we've got a function that we're calling on this shape variable, set fill color, and we're currently setting it to green. Okay, cool. So SF scope resolution operator color. This is probably something like an enumeration. If we're doing something like this, I can right click on this and go to definition, or I could peek definition, which will just bring up a little miniature window here. And so we've got a class called color. And then in this class, I'm looking for green. Okay, we've got some static variables. We'll talk about static a little bit later on. That's fine. And then, we've got green, which is just a color. And we have all these other color types. Okay, cool. So maybe I can change this to something else. What if we did yellow or something like that, right? So we do yellow and run that or spell yellow correctly. Didn't close that in time. Probably going to make that mistake many times today, forgetting to close that thing. And so now we have a yellow circle. Cool. Sounds good. Sounds good. And then let's look at the other stuff, right? So we have this while loop set up right here, while window.isOpen, right? And so what this is right here, this is essentially an event loop for a real-time application. So window.isOpen, if we just think about what that might mean logically, okay, so as long as the window is open, and of course if we just mouse over this, we'll see some comments that sort of describe what this actually does. But if the window is open, this function returns true. So this loop will just happen again and happen again and happen again, right? So we can have this kind of permanent loop in an application. And most real programs, real is not the right word to use there. Most programs which are far more sophisticated than simple programs we tend to write in an educational environment, especially in a fundamentals educational environment. Any kind of modern software that you're using, that will have one of these loops in it to some extent. Exactly how it's set up might change a little bit here and there, but otherwise your program, sophisticated programs will have this kind of a loop. This is pretty much standard stuff. So we're going to run this loop over and over and over and over again. Now, we then have something here, and this is a set of events. And we're not really going to go into all of these events today, or really in any of these lectures here. But generally speaking, events are certain things that can happen within your program, very common things that will happen in a program, like your program opened or your program closed, somebody hit a key in your program, somebody clicked a mouse, somebody moved a mouse, and so on. And we can have all of these different kinds of events. Just about every program out there, any kind of piece of software that we might install and run, will have a series of events supported, right? Because that's how our programs get to be more responsive, is with these different kinds of events. If the user minimizes a window or switches away from a window, maybe you want your program to automatically pause or something like that. That could be an event that we support. And so the only event that we have right now is if the event is equal to closed, then we close the window. And if we kind of think about this logically, if the window closes, then the window will no longer be open, which means this loop finishes, which means our program will get down to here, and then main terminates, which means our program is done. So when we close a window, our program will finish. That's essentially how all this is currently structured. And so this last little bit that we have here, this clear function, this starts to get into sort of graphics and whatnot, but generally clear is going to erase the screen, like shaking an Etch-a-Sketch, if you had Etch-a-Sketches, if you remember what those things are. But it's like erasing everything that's been drawn on the screen, and then we redraw whatever it is we need to draw again. So that might seem inefficient or wasteful or computationally expensive. And to an extent, all of those are true, but it's also what's necessary for these kinds of applications. And so what we're doing here is we're drawing this shape that was previously created. So there's a circle shape that was created, and then we're going to draw that circle shape. Its default location is all the way in the top corner of the window, which is 0, 0. So if we wanted to draw other shapes, if we wanted to draw multiple things, we could do something like this and draw a whole bunch of shapes, which currently that's going to draw the same thing right on top of itself every single time, which is really not going to look any different. But one thing we could do is maybe change the position of these shapes and then draw them somewhere else. And then this last function here, this display function, this sort of takes all of this work that we've done here and copies it over to the screen. It copies it over to my monitor. And that kind of finalizes this frame. So all of this code here, this is all one frame, one little tiny fraction of a second that occurs, right? And depending on what your program is, how fast it runs, all of this might happen, 60 times a second or potentially more, depending on what our target frame rate is, right? So, I'm not going to draw all of these right now because that would just put them all right on top of each other. And so, we can look at events and things like that a little bit more later on, but we can also look at those on the SFML website themselves. So we were to go to something like Learn, back to tutorials, then we have, scrolling down a little bit, events explained, right? So we come down here, then it talks about what the event loop is. It talks about different kinds of events, some common ones, things like closing a window, resizing the window, did we type anything or enter text, pressing keys, moving our mouse, all kinds of stuff like this, right? So there's tons and tons of different events. We're not going to talk about all of those, or you don't have to necessarily worry about all of those, but there are a lot of them there, right? So getting back to this here, if we wanted to try and, do some different things in our program, if we wanted to add some of our own code to it instead of just, pushing some buttons and modifying someone else's code, we might say, okay, well, let me see if I can duplicate some of what's already been done, right? So a circle shape is being made right here, and its color is being changed to yellow. Okay, cool. What if I wanted to try and do that myself? So we could say SF circle shape, and we can call this shape 2, and I'll give it a radius of, I don't know, 125. So Okay, now I've got a second shape, and let's say we'll do shape dot set fill color. And also, if we just use the period here, the membership operator, and we look at all of these different functions that these objects have, each one of these could potentially do something cool, something useful. And we might explore these. We might kind of, push some buttons again to just kind of experiment and see what these various things do. So if I do, for now, I'm just going to do set fill color, and we'll say red. So now, looking at everything else here, we've got clear, we've got display, and let's say finalize all drawing operations. Copy the results spelled properly to the monitor. This function should be called after all draw operations. And then this one right here, clear, should be called before all draw operations. And then in here, draw all the stuff you want to see on the screen. Right, whatever that might be, however many objects or whatever else. So if I were to take this and just copy and paste this and say, you know what, let's draw shape 2. The way things get rendered is essentially just like you were drawing or painting something. If you put down a blob of blue paint and then you put down a blob of red paint on top of it, the red will appear on top of the blue, assuming the paint dried or whatever else. Let's not get into blending and mixing because that's a whole other thing. You guys are doing enough blending with Project 2 right now. If you haven't started, then you have no idea what I'm talking about. But if you have, then you do. So if we run this, let's see what happens. And so now we have, interesting. Something seems a little bit wrong there. So we have oh, I know why, because I set this to shape instead of shape 2, right? So we still have the 2 circles there, kind of like an eyeball, that somebody says there in the chat. But because I set the shape color to red instead of shape 2, that's going to give me some problems. And let's run that again. There we go, right? So now we have the yellow circle in the background because that was drawn first, right? This is draw the yellow circle, and then this is draw the red circle, right? And so both of these circles are being drawn from their top left corner. That's how they're drawn by default. So from this location right here, a circle is being drawn that is however many pixels in size, or at least as a radius. And so the yellow one is being drawn first with a radius of 200, and then the second one, the red one, with a radius of 125, right? So, or maybe it's the diameter actually that we're specifying, not the radius. Seems about right. Okay. So yes, if this is an eyeball, there may be something wrong. Please go get your eyes looked at or whatever else, right? Yeah, your eye shouldn't look like that. Now we're drawing the one circle with red. What did we, instead of red, we did black. So that's basically just going to sort of cut out the other one, right? So now we get a moon or whatever sort of shape that we might want to call this thing, right? And so we can continue to do this kind of thing with other kinds of shapes. We could set up some kind of a loop or whatever. Whatever we might want to do with this. So let's pause here for just a second. Any questions, comments, concerns? And if not, then I'll just keep on going. You can ask some questions later on. So let's say we wanted to do something kind of like this, but maybe with more shapes. What if we wanted to draw a whole bunch of these things? What if I wanted to, maybe just draw the one shape in different locations? Or what if I wanted to draw this shape, just the one in a different location, right? So we could call, and let me change this to white here so we can actually see it. But if I do shape dot, and we take a look at these functions, we have a bunch of get functions, right, to retrieve some information. And then we also have a whole bunch of set functions. So I have a function called set position. And set position takes in, we have two overloads of this function. We have an overload that takes in a new kind of object called sf vector 2f. That's basically just a single object that contains an x and a y position. And then the f means that it's a float. And then we can also see another overload of this function, which takes in an x and a y. So I'll just use that one. So let's say we set the x and the y position to something like 375. And so if I run this, then that yellow object should be moved off to the side and we have it appear somewhere else, right? So we can change the positions of different kinds of objects to suit whatever our needs are. And we can do that, with a fixed position. It is always going to be in this one location. We can also do this dynamically. We can also set this position based on something like our mouse cursor, or we could change these values every time, right? So let's say, for example, I do something like, as a simple example, we say, let me put this up here. X position equals 300. And we'll just set this to X position. And so I draw that, and it's going to be at that particular location, right? And actually, let me make that a float. So now let's say every time we draw this in here, I do something like update the X position of the say plus equals 0.01f, which is not a whole lot, but it will make it move slowly. And so I change the position, and then I can also say shape dot set position. I'm just going to use 75 again. So it's going to stay at the same y position, but it will slowly move over to the side. I think this will be slowly. We'll find out. Could potentially just go flying off the screen, or it could move extremely slowly. Extremely slowly. It goes way off in the opposite direction, but it is moving. So let's maybe speed that up a little bit and run that again. Right. So there we go. Change that to 5 times as fast. It is moving 500% faster, which is still relatively slow, but that's okay because I didn't want it to go shooting off the screen because otherwise, well, that's maybe not the most exciting thing. Or maybe it is super exciting, right? Maybe you do want to see it just launch off the screen, right? Well, here's what we'll do. We'll do that for this other variable, for the tiny little the white star off in the distance, right? We have a big yellow star and a sort of a white dwarf off in the distance there. So let's say float x position 2 equals, we'll start that off at 0. And so here we'll do x position 2 plus equals, there we go. And then here we'll just say shape 2 gets updated by x position 2, and we'll leave that at 0, right? So now, still not super fast. I mean, we're still dealing with relatively small values here, but look at that white circle go. Just look at it taking off. It's in the lead, leaving behind the yellow giant in the dust, right? And so, yes, Julia, it is moving because the loop is constantly running. So as long as our window is open, this loop is going to run once. And then it's going to go back up to the top and say, is the window still open? Yes. Okay, let's do this loop one more time. Hey, is the window still open? Okay, let's do this one more time. And also in this is open function, it will essentially do some sort of a checks dealing with operating system specifics and all this other kind of stuff, and most likely put in a little bit of a delay. Like if the window's still open, okay, let me wait a tiny little bit of time. Let some other programs on the computer execute using some CPU cycles and whatnot. And then, oh, it's my turn again. Okay, great. Let's run one iteration of this loop and then we'll pause. And then we'll run one more iteration of the loop, and then we'll pause. And it does this 60 times a second, 100 times a second, over and over again, right? No, Richard, I'm not doing anything for the delay. Whatever system sfml uses, that's what the delay is. So I'm personally not doing anything. And if you're using something like a graphics library or some kind of an API like this, they may have something like that already built in. In fact, it might actually be the window, it might not be the isOpen function that's doing that. It may be the poll event that does that little bit of a wait in there. But one of these two functions will have that delay built into it. If we wanted to, add other kinds of objects, we could certainly do that. If we wanted to, let's make another kind of shape, let's say SF, we have a rectangle shape that we could make in addition to the circle, and we could just call this a box, and then box dot set, we could set the size of this thing. So to set the size of this, we need to give it an object of type vector2f, right? So we could say, let's do SF vector2f, and give it an X and a Y. So what size do I want this box to be? Let's say we'll do 150 times, I don't know, 80, just arbitrarily. And there should be floats, but I mean, we can convert 150 turns into 150.0f, that's fine. Then we can do box.set fill color. And so we can provide, or we can use an existing color, something like this, and choose one of these defaults in here. We've got, magenta, green, cyan, and so on and so forth, right? What we could also do is we could say SF color, or actually right here, we could call the constructor of this and say, well, I want to create my own color made from some red and some green and some blue value. So I could say, let's do maybe like 200, 0, 255 or something like that. So it'll be purple-ish, not quite magenta. If we did 255 of both, let's maybe reduce the red a little bit. Do something sort of like that. So if we, or no, I'm sorry, I just wanted to compile that, actually hit the button to run that, which will just give us exactly the same results because I haven't drawn this yet, right? And so now if we wanted to draw this box, it would be the same kind of operation here. We could even just copy and paste this and we could just draw the box, right? And so now we have a purple box up there. Cool. So if we wanted to draw multiple purple boxes, one thing that we could do is, this is just going to draw the one. Oops, there we go. Draw multiple boxes using a loop. And so that's funny, Angel. Let's go purple box. Purple box is not moving very fast, I tell you. So if we wanted to draw a bunch of these, then we could just do something like for I equals 0, I is less than 10, I plus plus. And we could do just a simple window.drawBox. That's all fine and good. However, this is not necessarily going to do what we might want, because this is going to draw the same thing right on top of itself 10 times, right? So what I might do is say box.set position, and we could say, I don't know, I times 100, and for the X position, and then for the Y position, if we wanted to drop that down a little bit, I times 125. So the very first one will still be at 0, 0, but then every time we increment I, we're going to move it over by 100 units and move it down by 125 units, okay? And so now if we draw this, which I really don't need this anymore, we'll get a whole bunch of those, right? And there we go. Now we have this little, kind of set of stairs, strange purple stairs floating in space along with our yellow giant and white dwarf, right? And so if we continue on with this, we could do potentially a lot of neat, interesting things just with drawing some simple circles and boxes, right? And so that's a far more complex question, Julia, making this thing bounce down the set of stairs. Richard, there is definitely a yield somewhere in here. It's in the sfml library, however. So it's either in the isOpen function for the window right here, or it's in the poll event. It's probably something like the poll event. Check if there's any events, and then if a certain time threshold has not been met yet, then just do some sort of a wait, some sort of a sleep operation. But that's built into the library, so I'm not sure exactly where it's located. But yeah, this isn't just an infinite loop that has unlimited CPU cycles. This is most likely only running 60 FPS, and it might even be 60 FPS by default. A lot of APIs like this will have some sort of dedicated intentional frame rate from the start, right? So let's see, what else could we do? We still have a little bit of time here, right? So what we could also do, we wanted to change the colors of these things as we move down. We certainly could, but that might involve sort of making a new sprite or something like that. If we change the box, it's going to change it for all of the boxes. Although no, not necessarily. It would change it for each one of those, right? Well, let's try something like that, right? So we could say box.setFillColor, and we'll do another SF color, and we'll do. We could say I times, well, there's going to be 10 of them. So let's say I times 25, I times, well, let's just try that, 0, 0. So it'll slowly get to be a brighter red. Or if we do I times 25 for both of these, this will kind of give us similar results to what we had initially. So here we start out with basically a black box all the way at the top, and then we get slightly brighter as we move down, as we get increasingly bright values there, right? So all kinds of neat stuff we can do just with a tiny little bit of code, right? And some of these things are things you've already seen before, right? I mean, we talked about classes. You know what a class is. You know what a loop is. You know how to call functions and all that other sort of stuff, right? Now, let's say we wanted to get even fancier. So drawing simple shapes, that's pretty cool. However, what if we want to do something a little bit more involved? So what do we want to create a sprite image and draw that, right? So although really this will be step 2. First, we'll just be create it, right? So in order to create sprites, we need a 2-step process. So we have step 1, create a texture. Step 2, create a sprite and set a texture for that sprite. And the type here is SF texture, and the type here is SF sprite. So step 1, I'm going to use a texture that I already have in place for this, or an image, and we'll say SF texture, and we can just call this texture for right now. So the image that I'm going to be using for this, let's see where. Well, that's fine. I'll just draw it, and we'll see what happens. So once I do that, create the object, we need to load an image from a file. So here I'm going to do texture.load from file. And this is going to be in a folder I have called images, and I called it space. And so this this space image is going to have like sort of a star field background. And once that's done, I make an object of type SF sprite, and we can just call this space sprite. And I'm going to, in the constructor of this, I need to assign it a texture. So I made the texture right here. I loaded something in for that, and then I set that to the sprite object. Now, once I have this sprite, the way we draw it is going to be the same thing as the same way that we draw all of this other stuff, right? So here we'll do window.draw, and I'm going to draw space sprite. So if we run this, and this is going to have a specific effect, right? So now we see just this little space background, right? And this is all, just an image that was made elsewhere in Photoshop or whatever else. So what's happening now, we're still drawing all of this other stuff, but the space image is being drawn on top of everything else, right? So that's like painting something amazing on a canvas and then coming in and painting something else possibly still amazing right on top of that. Both things are cool, but you only see the thing you drew last, right? Or painted last. And so if I wanted to see all of that other stuff, I would really want to move this first, right? I come up here and we have window.clear. We should always draw everything we want after window.clear. So, first thing we do is draw the background before everything else. So it appears behind everything else. So if we do something like this, then we should see all the stuff that we had rendered previously, right? And so now we have a space background and we've got some shapes, whatever these strange boxes are floating in the cosmos. And now we've got, yellow, our yellow giant and the white dwarf just zooming along, right? So I'm not saying, we've basically built some super sweet astronomy software here, but pretty dang close, right? We're about 80% there. All we need is, Saturn and, some space junk orbiting a planet, and then, boom, the solar system, right? So if we wanted to continue on with this sort of process, we could certainly create other kinds of sprites. I've got another sprite specifically for this, and we'll do sf texture station, and we'll do texture.load from file, images station, and sf sprite. So then I can come down here and I'm just going to copy and paste this, and we'll do station sprite. And ooh, something broke. Something broke. So we've got a little bit of weirdness happening right here. Not quite sure what that is actually. Let's find out. So we've got a little space station right here. However, the background's all kinds of messed up now. So there's space. We draw the station right on top of that. Oh, I know why. Because I used the same texture variable. That's why. So what happened here was this line of code. Oops, not what I wanted to do there. Overwrite the previously loaded texture. So this is bad because this is then going to, and this starts to get a little bit more complex than things that we've talked about. But behind the scenes, in terms of graphics memory, these images are set in different locations on our graphics hardware. And when I changed this load operation here, or when I overwrote the other texture, then I've still got a sprite that's referencing the old memory location, which now got overwritten with something else, and basically hilarity ensued. So we'll set this to be the right thing. There we go. And as we, do this more and more, as we need more textures, as we need more sprites, as we need to create more stuff, this all starts to get really messy really quickly, right? Just a handful of things, and we've got a lot of code here, right? So this looks a little bit messy. And it can certainly be very beneficial for us to write some sort of a class or classes, do something to help us make sense of all this, to organize all of this. Otherwise, we run the risk of main just getting bigger and bigger and bigger, and it's just a giant mess. If we're dealing with 5 variables, 10 variables, maybe that's okay. But if we started dealing with 20, 50, 100, that's going to be a bit more difficult for us to keep track of, right? So let me try running this again, and I think everything ought to be a bit better. There we go. So we have our background here. We've got our space station, still some bizarre random objects floating around, but you know, we've got a little bit more of a comprehensive thing than what we had before. So if we wanted to change the position of something like the space station, if I wanted to maybe center it in the window, we could certainly do that. But maybe, let's see here, to do that, we could say, now if we wanted to get exactly the center of the window, then we could say station sprite dot set position. Now what I want to do in terms of my position is I basically want to get my window and figure out its width and divide it by 2, because if the width is 1,000 pixels, or in this case 1,920, I can, just do the math myself and figure out what half of that is. But why do the math myself? I can have my program figure it out for me. And also, if I calculated this myself right here, if I did something like, oh, this should be 960. Well, what if I ever change this later to be something like 1400? Well, now suddenly 960 is invalid because I just hard coded that, right? So it'd be much better to calculate it instead of just assign it. So the window doesn't have a width variable, but this window variable right here, I could do something like this, window dot get size. And what get size returns is it returns an object of type sf vector 2u. So it's a vector 2, which is an x and a y, and then the u means it's an unsigned integer because we can't have a fractional size. So get size will return this vector 2, and I could call or reference its x variable, divide by 2. So now x is the width for window.getSize, x equals width, y equals height. And then do the same thing, window.getSize.y divided by 2. So now that's going to position this space station right in the middle of the window. Now, I say it's going to be in the middle of the window, and it is, but it doesn't quite look like it is, because the top left corner is right in the middle of the window, but it's drawing from the top left corner, so it's sort of offset by a little bit, right? So if I wanted to, really get this smack dab in the center, I'd have to do something that's a little bit different, which isn't tremendously difficult, but it will require just a tiny little bit more work with something called an origin of the object. And we're just about out of time, so we'll kind of leave it right there, right? But we can certainly build upon this next time, right? So within a pretty short amount of time, there's a decent amount of code here, right? I mean, we're up to what, almost, approaching 100 line of code, 75 lines. Now, a lot of this I didn't write initially, right? There's about 20 sort of starter lines of code. But it doesn't take much time at all in order to have something a bit more complex, right? And here we're drawing like the space station just the once. If we wanted to draw the space station in a for loop or something like that, we certainly could. We could change its size or color or all kinds of other sort of stuff, right? But we'll talk about some of those other things a little bit later on. All of this was just to show you that once you're working with someone else's code, some other library, you now have to leverage, what you already know. How do you write code with how do you use someone else's code, and how do you combine those two things together? We'll look at more of this stuff later on, but there, or for now, we'll leave it right there. Okay. So any questions, comments, concerns on anything that we looked at today? Let's see, Ryan say, what would happen if you entered a float greater than 255 for one of the RGB components? So the RGB values were only, they were unsigned integers, or they were unsigned characters rather, 8-bit integers. So it would most likely just overflow. So if I set it to say 256, that would really just set it to 1. Or if I set it to -1, it would underflow and set it to 255. That's most likely what would happen, which we could test that if I just tried it right here. And I say -1, -1, -1. This should end up white if it doesn't give me any kind of compiler error. So each one of the boxes ought to be just white. Yeah, there we go. Let's see. Oh, right. Yeah. Excuse me, Kevin. I misspoke. You're right. If we set it to 256, then it would wrap around to 0, not to 1. Let's see. Any other questions? You're welcome, Angel. Have a good weekend. Let's see, Ryan. What's the difference between a library and a framework? Well, a library is usually talking about an actual library file. And so, sfml might be considered more of something like a framework. We can kind of split hairs a little bit with some of these definitions. We've got things like libraries, APIs, software development kits, SDKs, frameworks. Usually frameworks and software development kits will be a bit larger, a bit more comprehensive. A library is usually kind of one thing, like it does one thing, it solves one problem. Even if that one problem might be very large or the solution might be very large, it kind of tends to do one thing. So sfml, for example, is maybe a little bit bigger than a library because it does technically multiple things. There's the graphics component of sfml, there's a network component, there's an audio component. So it's really not just a library, but it's maybe closer to a framework because it has multiple sub-libraries within it. If we build an sfml project, we might choose to link to only the graphics library or only the audio library. The library itself, the audio library, does audio stuff. That's it. The sfml framework, even though I might call it a library sort of informally, that might not be 100% accurate because it contains multiple sub-libraries essentially, right? So if that answers your question, perhaps, about the difference between those, Ryan. Let's see, other questions. Julia about Lab 6. Yep, you can certainly ask me that. If it involves, any kind of code debugging, then we'll have to wait until everyone else is done, or I could open up the office hours window or something along those lines. Let's see.
It's pretty quick, like generic question.
Okay, sure. Yeah, go ahead.
Any like viewing of code or anything.
Yeah, sure.
So, and I asked the TA about it and he explained it, but I'm still kind of confused. Basically, when I finished the lab, and when I was testing it I have Sea Lion. When I was testing it, the shape 2Ds all worked fine. Like the testing the constructor and stuff was good. And then when I was testing the constructor of the 3D objects, I was getting an error that basically was like pointer was deleted. Here, let me see if I can find the exact error message. I have it right here on Slack. But hold on one second. I have it right. My computer's very slow, but it's loading. Yeah, okay, so I was getting a pointer being freed was not allocated error. And so to fix the problem, I implemented a virtual destructor in my shape class and in the header and source file, and that fixed the problem, but I don't know why I would have needed to do that. Like, I didn't think that that was something I would have needed to do, but it did fix the problem, and now it's good. But I guess my first question is, why do you have to do that? And my second question is, why does it need to be virtual?
Okay, so you need to have a virtual destructor because when we're using polymorphism, we are dealing with some sort of base class pointer or base class reference, usually a pointer, because we're dealing with new objects and we later have to delete those objects. And so when we delete something, the only access we have to the thing is some base class pointer. So I have something like a shape pointer. I don't know what shape that is. Maybe it's a circle, it's a box, it's a rectangle, it's a strange polygon, or whatever else. But all I have to access it is a shape pointer. And so if I were to call delete on that shape pointer, I want to make sure that the right thing actually gets deleted, that the right destructor gets called. So we need to have a virtual destructor. So when I write a line of code or you write a line of code to say delete shape pointer, that really means delete the thing at the memory address the pointer points to.
Mhm.
If it's virtual, that will turn into instructions that say, let's check the type of data first, then call the appropriate destructor for it.
Okay, so like if in that case, since because that makes so much sense. The 3D shapes inherit from two different classes. So they have two base classes. So when you say virtually, when you have a virtual keyword in front of your destructor, that just signifies, okay, I need to delete the triangle, and like for the triangular pyramid, I need to delete the. Okay, wait, I confused myself. It made sense for a second. The light
Okay.
clicked and now it's off.
Okay.
But
So essentially, it just means destroy the object that I'm actually pointing to, whatever data type it might be. Instead of, if we didn't have the virtual destructor in our shape, we would only destroy the shape portion of whatever thing we made. So if you made like a triangular pyramid, which derives from, which derives from, which derives from, but it's ultimately a shape,
yeah,
calling delete on a shape pointer that pointed to a triangular pyramid would only delete the shape,
okay,
leaving the derived classes undeleted, or at least their destructors are never called.
okay,
Which means if you had any dynamic memory in those derived classes, they would be leaked and bad stuff could happen.
okay. That makes a lot more sense. Thank you.
Mhm.
Appreciate it.
And you can test that out in a simple way if you just make two classes, class A, class B, which derives from A, and then in main create an A pointer and set it equal to a new B. Then create a destructor for both of those classes and just print out a simple line of A was destroyed, B was destroyed, and then call delete on your pointer and see what happens. If it's not a virtual destructor, it'll only print out A was destroyed. But if it is a virtual destructor, then it'll print out B was destroyed, followed by A was destroyed.
Okay, so the pointer being freed was not okay. Yeah, pointer being freed was not allocated. It's all starting to make sense.
Yeah.
Okay, but yeah, that's a good way to test that in the future. Thank you.
Yeah, because when we're dealing with a whole bunch of classes like this particular assignment was, in part to kind of illustrate a lot of separate concepts of polymorphism as well as inheritance at the same time, because sometimes some of those features could kind of get a little bit lost in the mix.
Okay, yeah, that makes a lot more sense. Thank you.
Okay, you're welcome. Let's see, is there any other questions? Benjamin, you ask, oh, I see. Right, so every semester I teach two courses. Well, I teach three courses, but two of them are programming fundamentals to campus and online. So those are two sections that I teach. And then in addition to that, I teach one more class, which in fall is CAP 3027. And then the follow-up to that, I teach in spring CAP 3020. And those two classes are only offered in spring and fall, mostly because we don't have people to teach them every semester. I think historically that's always the way that it's been. And also enrollment is only so much. I think usually the first one, the one that I'm teaching in fall, tends to have a higher enrollment. The one in spring is usually a little bit less. I think last spring I had something like 30-ish maybe, but then I've got 63 or 64 in CAP 3027 this semester. So yeah, that's why that is. It'd be nice if I could teach both of those maybe every semester. However, then I would still have to do a third course, and doing 3 courses in a semester, 3 different courses, is not ideal. Just kind of changing tracks and whatnot, kind of bouncing from 3 separate topics is a fair amount of work. So maybe that'll change someday. Maybe there'll be other instructors who could teach it, but we're not quite there right now. I mean, I could also potentially not teach programming fundamentals, but I really enjoy teaching programming fundamentals, so I would like to continue to do so. Even though next semester is going to be an interesting one with the changes that were made. But let's see, any other questions here? Ryan, you're asking if a class were to inherit from 2 base classes, both with a function of the same signature, and the derived class were to call said function, how can you specify which one is called? So you should be able to specify that using the name of the class and the scope resolution operator. So you could, if class car derives from class bird and class vehicle, so it is now a flying car, right? A flying vehicle. If for some reason bird and vehicle had the same kind of function, whatever that function might be, then you could, in the code for that class, you could specify bird scope resolution operator, whatever function, or vehicle scope resolution operator, whatever function, to kind of separate those 2. You're welcome, Julia. Have a good weekend. Let's see. Nicholas, why does shape need a virtual destructor and not the other abstract classes? Because shape is sort of the grandfather of them all. And in this case, because in main, and if you take a look at the code in main, all of the objects that are being created, they're all being stored in shape pointers. And so we need a virtual destructor in whatever class we intend to use as a base class pointer, because we could have an inheritance hierarchy of 20 classes. If we only are ever using ancestor 0, or whatever we want to call the highest level in the hierarchy, if we're using that as the pointer, then we just need a virtual destructor in that. But if I was going a couple of levels deep and using one of those as a base class pointer to create some objects, then I would need a virtual destructor in that class. Depending on how your code structure is, you might have virtual destructors in nearly all of your classes, except for maybe like the lowest level of the inheritance hierarchy. If your program was set up in such a way that any of those classes, you might be creating one of those pointers and then setting that to, a class of itself or a derived class. But in this case, we're only doing that with the shape. Okay, so my code would break if it was shape 3D pointers. Right. So if you're only making, if we had a section of code that was only doing shape 3D pointers, and then, pointer equals new sphere, new cylinder, it would potentially break, yes, because we don't have a virtual destructor in the shape 3D class. Yeah. Let's see.
Another question if nobody else has one.
Okay. Yeah, go ahead.
So I was just wondering, like general debugging, is there a good way to compare the binary data from 2 files? Like for the car images, right? I was trying to like read one in and print it back out, and I checked them against each other. The only way I was able to do it was like open it in a text editor, but my text editor didn't have like a show diff function. So then I threw it back into CLine, which is the IDE I'm using, and then use their show diff. So I wasn't sure. Is there a better way?
You can do that, and that can work just fine. But really, I mean, and I suppose if you're using like an external tool that to be valid, instead of if you're writing your own tests, you're like, well, I screwed up my tests,
Right.
Which happens. A student is like, I tested. Here's my code for the test, and I look at him like, ooh yeah, oh yes, there is your code for the test. No, that's not right. I'm so sorry.
Right.
I mean, that can happen, right? Yes, I double checked, and I mean, I do this with my own stuff. Like I proofread it, and I went through it 10 times, and still there was a typo that I just missed. Um, it happens. So um, I'm not sure. I don't use any particular tools like that for comparing binary files. Depending on what kind of operations we're doing, it might not be something we need to do all that often. But basically, any kind of tool that has some sort of some sort of diff functionality in it, that should be fine, because all it's really doing is just doing a byte comparison, right? When we're dealing with things like characters, that's typically one byte at a time. Maybe more if we're dealing with like all kinds of other characters, symbols, and things like that that could go beyond one byte, but still more or less the same thing. Code wise, if you wanted to write a tool like that, instead of doing byte to byte comparisons in C++ or in C, which we can still use in C++, there are mem compare functions where you load in some buffer of data and you pass to this function 2 pointers, memory block 1, memory block 2, and then give it a number at the end. Compare from both of these blocks X number of bytes and tell me yes or no. Are they correct? So for comparing two files, you could open a file, read all of it into like one giant array of bytes, and who cares how the data is parsed or whatever, because that's irrelevant, and do that for two files, and now you've got two arrays of a megabyte each, and mem compare just says yes or no, they're the same.
All right, very cool. I know you use Notepad++. Do you happen to know if that has a show diff?
That's a good question. I don't know.
Okay.
I've never tried it.
No worries.
Like I
I'll
said,
look
I
into it.
not needed to do really. That's just never come up all that much in stuff that I've
Yeah.
worked on where I needed to do that sort of comparison. But it
Yeah,
might.
for
I
sure.
don't really know.
All right. Well, thank you so much.
You're welcome. Let's see. Any other questions here? Nicholas, I answered that one. Yeah. Okay. I'll keep doing this as long as I can, Benjamin. Eric, do you have a question? If you asked it earlier and I missed it, my apologies. They were scrolling by pretty quick. But go ahead, ask away. Let's see. In my project, my multiply function gives me a number that. Oh, in fact, I saw it right up there. I'm sorry, I kind of scrolled through that. Didn't seem like that was a question. Gives me a number that has one off from my green value. The first green value said there were 56.75. Multiplied it by, and it was still one off. Okay. I don't know. Offhand, I don't know what that might be. Maybe a small rounding error, possibly. I mean, that's my first thought, is a small rounding error. Yeah. Were you rounding them afterward? Like if you're using floats, add 0.5 to the end of it. $17 is supposed to be 16. Interesting. Okay. Yeah. Without seeing what your code is doing, I can only guess. Very commonly, it's a rounding error. But aside from that, I mean, I could take a look at your code possibly, but otherwise, I don't know exactly. That was kind of weird. 17 is supposed to be 16. Yeah, I don't really know.